G'day, I'm Lance from Motive Power. We're a specialist vehicle design consultancy based in Australia's beautiful Hunter Valley, and this is the start of a series of videos on professional off-highway vehicle design. Why do I say professional? Because I'm going to introduce some tricks that professionals can use and get the vehicle design right first time. Of course, none of this is advice. It is all guidance to suggest where you might want to find further information for yourselves. This series is focused on professionally designing the vehicles for off-highway use. Why off-highway? Why that term? Because very few vehicles are ever truly off-highway. A bulldozer cutting a new road might be, and a farmer crossing his paddock might be as well. But most vehicles operate on road, but off highway. Going down a bush track is off highway, but on road. So we're going to talk about off highway. We're going to use a lot of terminology because it's very important to get the terminology right when you're working globally, and that's the approach that we're going to take. However, I will be talking in Aussie English. We're going to spell things like tyres correctly with a Y. There'll be no Z's, just Z's. And there'll be a mixture of metric and imperial and US units. Maybe that's a bit messy, but it's the way the world works. And thank you, Fly. It's summer in Australia. Today's topic is all about tyres, but we are going to start off looking at terminology. Why is terminology important? Because you need to know that you're working on the exact same basis as the client. If the client is from a different country, different culture, different measurement system, it can sometimes be very tricky. You need to get it right, even if you've got to educate your client a little bit. Now, I'm going to talk about vehicles. The definition of a vehicle is a means of conveyance. That's why spacecraft are called vehicles, space vehicles. Trains are vehicles, trucks and buses and cars are vehicles, and I guess technically you could call a conveyor belt a vehicle, but we'll exclude that from this discussion. So let's look a little more at the terminology. So some terms that are very important. We're going to start looking here. F equals ma. You should all be familiar with that. Mass times acceleration and force. What people get confused with is that weight is a force. Mass is mass. The difference is the acceleration. In metric, 9.81 meters per second squared. But in imperial, it's 32.2 from memory, feet per second squared. A big difference between weight and mass, at least about a 10 to 1, but could be 32 to 1. Be very careful whether you're designing for a certain weight or a certain mass. There's a big difference. In metric, we would say the mass was in kilograms, the acceleration meters per second squared, and the weight would be newtons. you could say they're kilogram forces, but that would be unusual. It gets quite confusing in imperial because this is pounds mass, feet per second squared, and this is pounds force. Factor of 32 difference between those two. It's very common for us to have people quote the payload of a vehicle as a mass in pounds force or a weight in pounds mass. And then you've got to work out what the devil the client thought he was talking about. And the mass is usually quoted in tons. But what is a ton? In metric, it's 1,000 kilograms or 2205 pounds mass. Small t, sometimes we'll call it a tonny just because it differentiates it from other tons. Big T would be an imperial ton, 2240 pounds. And if you're American and like things to sound better than they really are, you have a short ton, which is 2,000 pounds. Big difference here, 10% difference. It may not be a major issue on a small vehicle, but I can tell you on a big vehicle carrying a few hundred ton, a 10% difference is a lot. One of the concepts I'm going to introduce to you is trust but verify. When your client tells you the payload he wants to carry, trust the figure he gives you, but verify it. Is it this, is it that, or is it that? Be very suspicious. You get this wrong, the whole vehicle design will be wrong. Of course, there's more terms. And the first one, when we look at a whole vehicle, is the tear. That's the empty mass. Except it's not always empty. There's often fuel, perhaps 10% of the tank is full, and a driver. Essentially, it's the minimum operating condition. Then we have gross vehicle mass, and that would be the laden vehicle. Fully laden. Maximum payload, full fuel tank, everything. And then there's gross combination mass, which is plus trailers. Laden trailers, laden prime mover, all up everything. Notice I've said mass. If you see someone quote gross vehicle weight in kilos or pounds mass, be very suspicious. They don't know what they're talking about. When we talk about tyre selection, it's basically done on what I'll call a ton mile per hour rating. Tyres are rated thermally because they have a flat on the tyre. Let's draw a tyre. There's a flat on the bottom. Put a center in it. To create a flat in a tyre, work has been expended to deform the tyre. That work manifests as heat in the tyre, and even in a Arctic condition, it can be 100 degrees C inside the tyre material itself. How much that's flexed is related to the weight it's carrying, and how often it's flexed is related to the speed it's doing. So this is the fundamental thermal rating of a tyre, a ton mile per hour. You look at how much you're carrying and how fast you're going, and decide on what tyre size you need. That's the start of it. But of course, there's always more. You need to understand the designations of tyre sizes. And I'm going to use an old friend here, 1825. I've used that a lot on heavy aircraft towing tractors. 18 inches wide on a 25-inch diameter rim. If I was to change it slightly and put an R in there, that would mean it's a radial tyre, whereas this designation means it's a cross-ply or bias tyre. If we look more at a car tyre, not really the focus of the video, but a good indication, a 165/70 R15. 165 millimeters wide, 70 profile, radial on a 15-inch rim. Yes, the units are mixed. It's a common situation. Get used to it. The profile, I just draw a cross section of a tyre simply here, and I say that's the width and that's the height. The height is 70% of the width. That's quite a low profile for an off-highway vehicle and would be unlikely to work. If we go into smaller tyres again, we get designations like this, 20 by 10 by 12. Something that might be used on a Polaris UTV, for example. That's 20-inch OD, 10 inches wide on a 12-inch OD rim. So that's tyre designation. But wait, there's more you need to know still. So here is a Bridgestone catalogue, and it's a great indication of the range of tread patterns available in common off-highway. You could also look to agricultural tyres for another range again. But we start with earth mover, it's the E designations, and you'll see even within E2s and then E3s and ultimately E4s, there's a huge range of tread patterns depending on what you need: traction, reliability, long life, high speed, steering, driving, or both. E3s, E2s, E4s are quite commonly used. You'll even see here in a minute some slick tyres that would be used on hard standing, like a waterfront port. We start to get into duty cycles, cranes, industrial, and so forth. And one of the things I like most about this catalogue is this diagram. It shows the compromises that are necessary when designing a vehicle and selecting tyres. You'll see heat resistance is the opposite of cut resistance. Traction is the opposite of rock. So you can't necessarily have a heat resistant, cut resistant tyre. What you can have is a compromise in the middle, similarly with traction and rock. Excellent thing to keep in mind when you're selecting your tyre patterns. So here we are on the farm to see some real world examples of tread patterns and why they were selected. The vehicle I'm leaning on, to my right, is a Ventrac 4500P. You'll hear a bit more about it shortly. The vehicle on my left is a Polaris 570 Ranger. Two vehicles on the same property but with different applications. Let's see what impact that has on their tyre treads. So despite its small size, the Ventrac is a fairly serious tractor. It's a bit of a beast actually for what it is. And as a tractor, it has to supply a lot of tractive effort in all conditions. So the tyres selected have a lot of rubber, somewhat open to clear the mud and so forth, but a lot of rubber with which to contact the ground, therefore working really well in good ground conditions, hard ground, and even on grass. The Polaris, on the other hand, well, it doesn't have to provide excessive tractive effort. It tows only a moderate amount and only carries a moderate amount. So its main effort is to move itself. And these tyres are optimised to do that in the worst possible conditions, i.e. mud. I can tell you from experience, even in two-wheel drive, they work really well in deep mud, at least up to the chassis. So two tyres operating on the same site but different applications and therefore different treads. More rubber for good conditions, less rubber for bad conditions. Ply rating is also something that you need to deal with. That's the amount of reinforcement in the tyre. Including that, tyre designation, using Old Faithful again, is going to start looking something like this. (1825) E4, which is tread pattern, and now the ply rating. The final part of that is the pressure that it needs to be to carry the necessary load at the necessary speed, at the duty cycle, and so forth. There's the full designation of the tyre in service. If we're talking high speed highway tyres, we'd probably have a V rating as well. Because of the high velocity, that's not going to be applicable to off-highway here. When we talk about standards, we'll also talk about duty cycles, because that's important. If you've got a loader, it's a much lower duty cycle than perhaps a crane, because a loader is only fully loaded half the time. That means the thermal loading on the tyre is less. You need to consider that. And then ultimately, you'll need to know what size the tyre is physically. There's a tyre with a centre. You'll need to know the dimensions of it, because it's got to fit the vehicle. So obviously, outside diameter is important, fit the wheel wells. But so is the static loaded radius, because that's what sets the height of the vehicle and your ground clearance, etc. This is sometimes derived from something like revs per kilometre. You can back calculate that dimension. Of course, this one's static, this one is dynamic, this one is more accurate for things like speedos, this one is more accurate for the physical dimensions of the vehicle. So despite its small size, the Ventrac 4500P is a 31 horsepower tractor of fairly significant capabilities. You'll notice it has dual tyres. As standard, they're single tyres only all around. And the vehicle is quite functional, up to 20 degrees in slope. Now, I said this is a 4500P. For some crazy reason, the P designates the V-twin Kawasaki petrol engine, which is rated to 30 degrees slope in any direction. By adding the dual tyres all around, the vehicle itself is then rated to 30 degrees, and it works well at that. But this is an example of why tyres are sometimes selected for other than load speed characteristics. It's Australia in summer, there's flies. So sure, the inner tyres have been selected for loads and speeds. The outer tyres match them, but with two tyres all around, it offers a wider track and therefore a much more stable vehicle. While we're here with the Ventrac, it's a great opportunity to talk about dual tyres and the load sharing on them. I've just run this inner tyre over a half brick to simulate perhaps a rut in the road. The outer tyre has been completely lifted off the ground. I can show it with this stick passing underneath. That is why dual tyres don't carry double the load of a single tyre, because you can't rely on the load share. As this moves down the road, the load's likely to transfer from one to the other, and only in relatively soft ground will it be equal loads on each tyre.
So let's talk about standards. There's an example of a standard. Good hefty document, goes on for hundreds of pages. That's the Australian Tyre and Rim Standard. That one's a little bit dated.
I know there's an Australian one, there's an American one, there's the European one. You can in fact use them to select tyres from different countries. I've in the past used European tyres because they could carry more than American tyres under the standards, but they will tell you a whole lot of things you want to know, from basic dimensions to the right rim sizes, the duty cycles for loaders, cranes, graders, all sorts of different things. You'll be able to determine the tyre pressures, the tyre sizes, what happens when you've got dual tyres, because dual tyres don't double the load, and we'll show you why not later. A whole lot of info. Read them, get very familiar with them. In particular, read the fine print. That's where the magic happens. For example, in the fine print, generally at lower speeds and higher pressures, you can carry some very significant loads. So catalogues can provide a lot of the details, and the standards set the overall requirements and the duty cycle information. But they're all a guide. You need to talk to your suppliers and get the real facts on the tyres you're going to choose to use yourself for your particular application. In the past, I've always found distributors better to talk to because they can offer a wider range of sometimes oddball tyres. Mainstream suppliers are really good for mainstream product. When you're getting a little off the norm, you maybe need someone with a different product range. Now, there's always more special requirements and unusual requirements. Behind me, about there, is a model of an International Harvester pay hauler 350. It is a little unusual in that it has dual tyres all round, front and rear axles. The steering axles have dual tyres, and it was done that way so that there was an equal tyre loading all around the vehicle, laden and unladen. That meant the tyre life was extended. That's a big thing for a haul truck. There are also lots of other examples. If you're designing a Dakar truck, there we go, you want big tyres. Certainly don't want to sink in the sand. You want low rolling resistance in sand. You also want very high ground clearance. So you're going to be interested in the OD of the tyre more than you would if you were just running down a normal road. And of course, if you're in a trophy truck, stadium racer, Baja, again, big tyres for the same reason. And then trust the French for the really weird examples. This is a Michelin tyre tester. You'll probably recognise what it's based on, but has a lot of tyres for a very special reason. It's there to test tyres, and not the tyres on the normal axles. The tyre that's mounted in the middle of the vehicle up under here. Probably can't see it. Let me see if we can get a bit of lighter background behind it, but take my word for it, there is a tyre there. By putting it there, you can change the angle of attack, change the loading on it, do lots of unusual things in an actual test. So another example of a weird and wonderful requirement that certainly isn't in the standards and won't be in a catalogue either. There are also specialised tyres. Some examples are non-marking tyres that are typically used in warehouses with epoxy floors, but people don't want black marks left on their nice pretty floors. There's non-sparking tyres designed to prevent the build-up of static, and they're typically used in places like oil refineries, chemical plants and munitions factories, because you don't want to spark in that application. In mining, certainly in underground mining, where I've done a lot of work, a lot of the tyres are solids or foam filled. Um, Basically, they don't get punctures. They sustain an awful lot of damage without going flat. One particular thing to watch with foam filled tyres is don't exceed the speeds and distances. If you do, the tyres get hot. Remember, tyres are thermally based, and in that case the foam will turn to liquid and you've ruined the tyre. There's also run flats that the military would use, but that's an entirely different subject and a very specialised one we'll leave to somebody else. Also now available, particularly in smaller sizes for things like UTVs, are the Michelin wheels. It's a combination of replaceable tyre tread pattern on top of a flexible wheel. New to market, not much experience with it, so we'll see how it progresses, but it is perhaps a viable option to have a client looking at it for run flat applications. I'd also like to introduce a rather unusual application, and this is an FWD brand missile prime mover. It's using Rolligon tyres. These are very soft wall tyres, essentially bags. They're designed for snow and muskeg. Not much muskeg in Australia, so I don't have any experience with them directly. But the distinguishing factor is that they're driven by a friction roller on the circumference of the tyre. So the traction loads are going directly into the circumference of the tyre and not into this baggy soft sidewall. Here's a shot of it as a prime mover with the Mace missile in launch configuration, not transport. And the trailer was similarly equipped with Rolligons as well. They are still available, I understand, but they're quite rare. So, we understand tyres now, but what do we put them on? Well, typically it's a rim that looks like that. And there'll be a matching thing on the other side of it, centre through there. The standards will give you the rim designations, but they won't necessarily tell you all the story. You need to make sure you're buying rims from someone who knows what they're doing, particularly if high loads or pressures are necessary. This is a rim. If we put a flange or a centre in it, it becomes a wheel. So this bit is rim, the whole bit is a wheel. Sometimes all you need is a rim. Most times it's a wheel. You need to get your terms right. Again, you can make yourself look silly by using the wrong terms. So, standards give you a guide, catalogues help you more, but there's still a few things that you need to know, and they're traps. You need to know what the wheel nuts are. If they're standard cone nuts, the sort of thing that you might have on your car, a tapered section on the inside of the nut, that is what will locate the wheel concentrically with your axle. Some axles come with spigots that will locate the tyre or the wheel as well. You shouldn't use both. Don't use cone nuts on an axle where you're using a centre spigot. That's a duplication and you're going to get some problems. Whatever you do though, be careful of your nut torque and make sure that you're successively, repeatedly tightening the nuts throughout the first few days of operation. Nuts and studs in particular will stretch and settle in. There's also the issue of surface preparation, surface treatment. If the wheel is painted, the axle is painted, and you clamp it together, that paint is going to wear and it's going to loosen the grip. Personally, I prefer those surfaces not to be painted, be greased and left like that. Powder coating may be better, but I don't have experience with that. But be very careful to make sure that that clamping action is done properly and it's checked repeatedly shortly after production. There are also situations where you want to ballast the vehicle up. Farmers will often add water to a tyre, and that's fine. Typically have a bigger bore valve and tyres and wheels that are designed for that and won't rust. If that's not sufficient, calcium carbonate can also be used. That has a 30% higher density. Again, special valves are required, and I have no idea how you ever get it out. Final thought is a non-technical one. Custom car builders know that wheels are the most important part of their design. They're actually wrong. It's the tyres that set the wheels that are the most important part. The tyres have to look the part, or you will never get the vehicle to look right to the eye. And getting it right to the eye is important, because if your customers like the appearance, they will like the vehicle. If they don't like the appearance, you're starting from 3 steps backwards and the customers will complain about everything. So, that's it for tyre selection. I hope it was useful, and I look forward to having you back for the next episode.